Welcome! Today we'll solve a problem about propane combustion and heat transfer. Let's say we're cooking a pork roast on a gas barbecue, and we need to figure out how much propane we'll need. Let's look at what we know. Propane combusts according to this equation. C3H8 plus 5. O2 produces 3CO2 plus 4H2O. This reaction releases 2,046 kilojoules per mole of propane. We need 1.6 times 10 to the 3 kilojoules to cook our roast, and propane has a molar mass of 44 grams per mole. Let's solve this step by step. First, we need to find how many moles of propane will release 1.6 times 10 to the 3 kilojoules. We can divide the heat required by the heat released per mole. That's 1.6 times 10 to the 3 kilojoules divided by 2,046 kilojoules per mole, which equals 0.7820 moles. Next, we'll convert moles to grams by multiplying by the molar mass. That's 0.7820 moles times 44 grams per mole. This gives us 34.41 grams of propane. Finally, rounding to two significant figures, as requested, we need 34 grams of propane to cook our pork roast. This assumes all the heat from the combustion is transferred to the meat, which is an ideal case. In reality, you might need a bit more propane since some heat will be lost to the surroundings. To summarize, we found the moles of propane needed by dividing the required heat by the heat released per mole, then converted to grams using the molar mass. This kind of calculation is common in thermochemistry problems.